Okay, so this is kind of our part 2 of properties of exponents. So these ones are all dealing with division and exponents. So I'm going to go through the properties first, and then we'll do some examples. So property 4, this is the one that causes people trouble. It really is just if you have a negative exponent, it's not considered simplified, so we always have to rewrite them as positives. And if that negative is in the numerator, so you can kind of think of this as over 1, it just shifts down to the denominator and becomes positive. Likewise, if it's negative in the denominator, it just shifts up to the numerator and becomes positive. So if it's negative, you just put it in the other place and it's a positive exponent. Property 5 is that when we're dividing, we can subtract the exponents. The reason that works is if you kind of think of what this is, if say I had x to the 5th over x to the 3rd, that would be 1, 2, 3, 4, 5 x's over 1, 2, 3 x's. And if I cancel, an x over x would just be 1, so those all just reduce out. You'll say I have 2 x's left, which would be x squared, which is the same thing as if I just said 5 minus 3, leaving x squared. So that's what that property is doing. A lot of times I'll just think of it as canceling, and I'll talk about that a bunch in this one. Property 6 is kind of like property 3 in the last one. It just says the x goes to both the numerator and the denominator, so both of those would get that power. And then a couple of definitions. X to the first, we've seen that a bunch. That's the same thing as just plain x. And then anything to the 0 is 1. And the reason for that, okay, sorry, my kids got home there. So the reason that x to the 0 or anything to the 0 is 1 actually comes from this previous definition up here. So I'll just do a quick little example to explain it. So if you think of having 2 to the 3rd over 2 to the 3rd, that's the same thing as having 8 over 8, which would be 1. And you can kind of see if I have, some base, the base has to be the same, but, because that's this case up here. But if the powers are the same, when I subtract that, I'm going to get 2 to the 0. And that's just because since these powers are the same, they're always going to cancel out and make 0. But the powers are the same, so it's the same number, so it's always going to make 1. So therefore, we can kind of figure out that 2 to the 0 does equal 1. And it's going to do that for everything. The one case is if x can't be 0, and this 0 to the 0 isn't defined. So that's kind of the toolbox for this section. And you'll see there's a bunch of different ways to do these problems. There's usually about 2 ways, 2 general ways, but often a couple of different paths from there. So we can apply property 5 first or property 4 first. We're going to see that a bunch as we go through. These first few are fairly friendly, and then I'm going to try to do a bunch of the examples kind of 2 different ways. Just pick the one that makes the best sense for you. Some people like one version and some people like the other, so I try to give both. So this first one, we just have 5 to the first, so 5 to the first would just be a 5, because that's 5. Anything to the 1 is the same thing as just the thing. 5 to the 0, that's that one, that's just 1. 5 to the negative 2. Okay, so now we got our property 4 coming into play. When we see a negative like that, we want to rewrite that as 1 over, and then 5 to the positive 2. So this and this are the same thing. This is just considered more simplified. We want to keep going though. Don't leave it with the power. Go ahead and go 5 squared and get 25. This one, so this one, the 2 and the x are both affected by the negative 3. So that would be 1 over 2x and then to the positive 3. And now I can take that cube through, and that would give me 1 over 2 cubed would be 8, and then x cubed. Number 5 looks a lot like number 4, except here the 2 is not being affected by that negative 3, or it would be in parentheses like this. This is kind of like if we had, say, 2x cubed. This cube, it doesn't make that 2 and 8, it's just working on the x, but there's something with the negative exponent where people want to end up applying it to the 2. So in this case, the 2 just stays put because it's just a plain old 2. But this x to the negative 3 is acting like this. And so instead of writing like that, I would say just think of it as 2 and then over x cubed. So just this x cubed moves to the denominator. Again, that's that property 4. So this next page is what I would have you guys try in class. The first one will go 1 over 4 cubed, and then 4 cubed to clean that up will be 1 over 64. Number 7, the negative 5 is not working on the 13 because otherwise it'd be parentheses. So the 13 stays in the numerator, and then that x comes downstairs, and then with a positive 5. For this one, there's a couple of ways to do that. So we can use we could use the property we had from the last section, which is a to the x, a to the y equals a to the x plus y. Or we could also do it the way we would do it in this section. So honestly, the last section's version is easier. That would look like x to the 7 plus a negative 2, and then 7 plus negative 2 is x to the 5th. So if I think of it as this section, I could rewrite this negative exponent, x to the 7th over x to the 2nd, because this is negative, it belongs in the denominator, and then think of it as x to the 7 minus 2. So you can see it's the exact same math, just plus a negative, and this one's minus, same thing. And I still get x to the 5th. From here, I could also think of it as having 7 x's up top, 2 down below, canceling 2 of them out, and that would leave me 5 up top. That's actually kind of how I tend to think of these. Although presented this way, I think I would just add them and get that. So that's kind of what I was saying at the start. There's a lot of right ways to do these, and it's whichever way you see that makes sense is a good one. For number 9, so anything to the 0 is just a big old 1. And that's all to be done there. For number 10, we have 5 to the 0 in the numerator over 5 cubed in the denominator, so that'd be 125. Okay, this next set would be me on the board. Here, again, a couple of ways of thinking about it. For me, I actually just think of this as, like, this really means there's like 4 5s multiplying, and this means there's 7 5s. I would just think of it as canceling out 4 of them, and that would leave me 3 downstairs. And so it would look, these look like S's because I'm making fast little 5s here, but it's basically I have 4 up top and I have 7 down below. So I just think of it as kind of doing this, and that makes me see I have 3 left downstairs. And when the whole numerator cancels out, that's where we need that kind of 1 placeholder. And so then this would be 1 over 125. The other way to think of it is 5 to the 4 minus 7. So then that would be 5 to the negative 3rd. And then applying property 4, we're going to go 1 over 5 cubed, and then there we are back here. Number 12, so again, multiple ways to go. If I apply the subtraction property, then I would have 5 to the negative 1 minus 3, so it's just this minus whatever that is, would be 5 to the negative 4, which would be 1 over 5 to the 4th, and then 5 to the 4th is 625, so it'll be 1 over 625. So that's one way. Another way of thinking of it is, so this 5 to the negative 1 should be in the denominator. So if I rewrite it downstairs, then I have 5 to the 1st, 5 cubed. So this is applying property 4 first instead of property 5 first. Then that gives me 1 and 3, so 5 to the 4th. And then I'm right back to that same answer. So there's kind of a couple of different ways you can get there. Here, if I apply, and I'll just kind of keep doing where I apply the subtraction one, the division, property 5 first, and I'll do where I apply the second one, or property 4 first. So here, x to the 4 minus, and careful that you get that negative 5 there, so it's minus whatever is here. So if it's negative, it stays, it's minus a negative. And that would make x to the 9th. You can also think of this as x to the 4th, and that this thing should move up to the numerator. And then you can also just 4 and 5 for x to the 9th. Here, let's see. So I'm gonna do the version where I flip it first, just because I think it looks better off to the side like this. So this x to the 11, it should be up top, and then this x to the negative 5, because they're negatives, so it should really be downstairs. And then for me, if I just think I have 11 up and I have 5 down, I could just cancel out 5 of them, and then that's going to leave me 6 up top because that's where I had the most. So if I thought of it like all written out like I did here, I would still have them left in the numerator. If I do it the subtraction way, that's going to be x to the negative 5 and then minus a negative 11, which is perfectly fine. You just have to be careful with the signs is all. And then, so that would be minus minus, which would be plus, so negative 5 plus 11, and that's that same x to the 6th. Okay, this page would still be me. So if I do it where I move stuff first, this would be 1 over x to the 7th, and then this negative 3 would come downstairs, and that gets me 1 over x to the 10. So I'm just adding those to get the 10. If I use property 5, I'd have x to the negative 3 minus 7. So x to the negative 10, or 1 over x to the 10. Here, I think I'd probably distribute that negative through just because it's going to kind of flip all the signs inside. So if I do that, that would look like x to the 6th over x to the negative 10. And then I can think of this should really be in the numerator, so that would be x to the 6th, x to the 10th, or x to the 16th. Or from here, the alternative would be x to the 6th minus negative 10, which is still x to the 16. So again, whichever one makes better sense for you, do it that way. They're both equally valid. Here, x to the negative 7, and then 4 times 2 would make this one x to the 8. This isn't in the right place, so I would think of it as dropping it downstairs, and then that helps me see I have 15 x's down there. If I do by subtraction from here, this would look like x to the negative 7 minus 8, or x to the negative 15, which is 1 over x to the 15. That one a little bit more complicated. So we're going to have 2 times 4, so that'll be x to the 8. 5 times negative 2, so that would be x to the negative 10. And then here, x to the negative 18. I could rewrite them as positives. I could collect the numerator. There's lots of right ways. I think I'll collect the numerator first and go, so 8 plus negative 10 would make this negative 2 up top, and then x to the negative 18. I could think of flipping these. The 18 would be up, and the 2 would be down, and if I cancel out 2, I'd have 16 up top. Or from here, I could also do x to the negative 2 and then minus negative 18, and that gets me the exact same x to the 16th. Okay, and the rest of these are the ones that have you guys try in class. So here, just 5 minus 3, so that will be x squared, or just think of it as canceling out 3 of them. For 20, I could do x to the 8 over x to the 12. And if I cancel out 8 of them, I'd have x to the 4 downstairs, or x to the negative 12 minus negative 8, which would be x to the negative 4, which gets me the exact same spot. Here, this x to the negative 7 should really be in the numerator. So that would be 11 and then 7, which gives me 18 altogether. Or by subtraction, 11 minus negative 7, and there's that same positive 18. For here, I would think of it this way, where the 3 should be downstairs, and then that's going to give me 1 over x to the 25. Or you can think of it as x to the negative 3 minus 22 makes x to the negative 25, and then bring it downstairs. You're right back at that answer. So let's see, this one. Oh, this one has a little tiny tricky bit here, that negative 5. So if I bring this downstairs, it doesn't change the negative 5. So 2 ways of thinking. I think I'm going to go with the one where we distribute, because I think that's going to be cleaner. So I'm going to go negative 2 times 1 is going to be 3 to the negative 2, and then negative 2 times negative 5 is going to be x to the 10th. And so this is going to end up x to the 10th over 3 to the positive 2, or x to the 10th over 9. And the thing I started to say up here, I'll just go ahead and show it, because someone's going to try it this way, if I do this -2 and I write this as 1 over, the 3x to the -5, that -5 doesn't change. That whole thing is like a. So the only thing that does change is the 2. And then that would look like 1 over 3 squared would be 9, x to the -10. And you said I'd have to bring the -10 up, and then I'm right back here. But I think this way is a little bit easier. Number 24, I'm going to go 6 times 4. So that would be x to the 24th over x to the 14. I would just think of it as canceling, leaving me x to the 10 up top, or 24 minus 14 leaves 10. Let's see. This one, we're going to go, do it a couple of ways. Could reduce first. I guess it doesn't matter. We'll go, let's just do what probably you guys would do. So x to the -6, and then x to the -10. I could have also made this 1 over x squared and did the reduction first, but you'll see we end up in the same spot. From here, I could go bring the 10 up, and I'll bring the 6 down, just so I have positive exponents. And then when I think of canceling, I can see I have 4 left up top. The other way I was thinking was 1 over x squared, so just canceling right away and having 3 up and 5 down, so I'd have 2 left downstairs. Or I could do the subtraction, get the -2, and then multiply it by this -2, get this 4. From here, I'd have 1 over x to the -4, which I'd then have to flip up and make x to the 4. So there was like 3 different ways to get to the same x to the 4th. So there really are lots of right ways to do these ones. Here I got 6 times 7, so that's going to make x to the 42. 2 times 11, that's going to make x to the 22. And then 42 minus 22 will be x to the 20th. And here's these last couple. So here I'm just going to multiply that in because it's going to flip all the signs to positive. So that's going to be x to the 4th over x to the 10th. And then I would just think canceling, making it x to the 6th. Or if you prefer, 4 minus 10, making x to the -6th. And there's that same 1 over x to the positive 6th. And this last one, so we'll clean up all these little multiplies first. So that's going to give me x to the 10th, x to the 10th again, and then x to the 24. Here, x to the 10th, x to the 10th, so we're adding exponents, because it's just like I have 10x's, 10x's. So that'd be x to the 20, x to the 24, and I would just think of canceling, and that will leave us x to the 4th. And same thing, you could also do x to the 20 minus 24 and get x to the -4. For me, you can probably guess by now I prefer this way, but a lot of people prefer this one. So whichever version has been making better sense, just stick with that.